Hello, my name is Alejandro Suárez, and I'm with the Institute of Robotics and Industrial Informatics in Barcelona. We developed the planning component of the Imagine project, which takes care of deciding ahead which actions to execute during a disassembly sequence of a device. In this video, I want to give a very brief and informal overview of a publication that we made in collaboration with our partners from INSA, in which we seek to combine the ability of the planner to look ahead with the potential of physical simulators to learn about actions before executing them. The main motivation of our work is that we often encounter situations in which there is more than one possible way to approach a specific task. This is one such example of such a scenario in which we have a GPU with a cooling unit mounted on top, and we have two possible actions to remove this cooling unit. The first one is levering the cooling unit, and the second one is just flipping the device around and letting the cooling unit fall. And as you can see here, the lever action fails because it gets stuck due to the multiple lamps and irregularities on top of the PCB. And on the other hand, the flipping action succeeds. These are some of the actions that we can execute in the simulator, all of them targeting the same component and all of them with the same intent of removing this component. And the main premise of our work is that the physical simulator allows us to see before executing these actions which outcome is the one that we will get. And thus we can combine the ability of the planner to decide strategically which components target and in which order, with the ability of the simulator to actually decide which specific approach should we take for each component. One of the very first things that we study in our work is the trade-off between simulation time and simulation accuracy. As it happens, we use 3D models of the device that we want to simulate, and the higher the polygon count, the more time we have to invest per simulated action, but we get more accuracy out of that simulation. This is what we see in this plot. As we increase the model quality, we increase the time per simulated action, and we decrease the accuracy of the simulation. However, we can see here that the accuracy does not decrease linearly as it happens with the time, and thus we can settle with an intermediate quality that doesn't incur in much time penalty, and that it's reasonably accurate for our purposes. In this work, we present a bandits-like approach to interleave execution of actions and simulations in order to gather enough experience to progressively build the probability of success of the different available actions for a specific task, in this case removing the PCB of a hard drive. And we can see here one of the successful actions for this specific task, both in simulation and with the real robot. And of course, we can also visualize one of the unsuccessful actions, in this case because it misses the PCB and doesn't actually get to push it away from the device. In contrast, we can see what happens when simulations are not available, and we learn the probability of success of the different actions by executing them directly with the real robot. Since we penalize each failed attempt, we can see here that we incur in a large penalty at the beginning of the task before the robot is able to identify the most successful action and try to catch up with the previous execution with interleaved simulation and real executions. So the main takeaways of our work are that, well, first, that we can learn about the different available actions without incurring in any risk of, for instance, breaking a component or simply wasting time with unfruitful actions. That we can combine real and simulated experiences together to refine our knowledge of the actions, to refine the probabilities of success of the different actions, and we do that in a way that puts more weight on the real experiences, and eventually the real experiences will take over and our probabilities will converge to the probabilities of the real world. which is important in case that the simulation shows some bias in a very specific scenario. And with that, I would like to conclude this video. I hope it's been informative. And if you are interested, I invite you to learn more about our work, which has been published in the IROS conference from 2020. Thank you for your attention.